But okay, let's begin our seminar. The title of tonight's seminar is Brushless Motors, LiPo Batteries, and what may become the future technology for the growth potential that model submarines need. It's some of the lab work that I've been doing in my spare time, and I hope that we may have actually found something that can help us out in one of the big questions that has been coming up a lot lately in the model submarine community. We're going to start out with the brushless motors. A lot of people, both in the subcommittee and in the Colorado crew, are constantly asking, you know, why do I want to use a brushless motor? Or the brushless motor that I picked up at the hobby shop is not what I need. And I'm just here to give you what I have experienced. I gladly stand in front of everybody and say, yes, my name is Tim Senecal, and I'm a brushless bigot. Every single submarine that I own, and I've got 5 of them running and another 2 being built, and 1 that I no longer possess, so that makes a total of 8. Every single one of them is brushless. And every one of them but the Alvin is using LiPo. There's a lot of second-hand information that's being passed around that may or may not be factual, and I hope that the information that I give you tonight, based on personal experience, can be first-hand knowledge, not second-hand knowledge, and stuff that I know personally works. And a lot of it, we've had discussions all day today with different members of the subcommittee, and a lot of people just want to have things that they know they can go and buy so that they don't have to think about it. And to be brutally honest with you, I don't think that the brushless technology has matured to that state yet. I don't think that there's enough background for you to just go to a hobby shop and say, I've got a model tugboat or I've got a model submarine and I want to put a brushless motor in it. Because I can tell you right now, you're not going to be able to buy a ready-to-run model tugboat that has a brushless motor in it. The cost difference between, for a manufacturer, he's going to buy, you know, in quantities of 1,000, a brushed Japanese motor is going to be $1 a piece. A brushless Japanese motor is going to be $5 a piece. So there's still no benefit to a manufacturer going with a brushless motor until he absolutely has to. And you're going to end up with something like the Miss Budweiser here, which is designed to go 50 miles an hour and in fact exceeds that capacity by a small margin. But as far as what I have done with the brushless motors is I've basically discovered that there are other RC groups out there that have done a lot of the legwork for us. And a lot of the technologies that I've incorporated in my latest generation of submarines come directly from the RC crawlers, because they need exactly the same stuff we need. They need a low RPM, high torque motor that has the same exact performance envelope that we need for our tugboats and our submarines and our other large, slow-moving scale vessels. So it's finally reached a point where the Chinese manufacturers have started picking up on that fad. You know, there's a lot more RC rock crawler people out there than there are model submarine people. So we've kind of benefited from their labors. And both the Skipjack and the Delta are using RC rock crawler motors and speed controllers as their primary motor. And because the speed controller is programmable, I'm actually setting these up so that the motor's running at about 550 kV, which means for every volt that you pass through the motor, you're going to get 550 revolutions on the motor. Both of these boats end up spinning the propeller at about 4,000 RPM, which is exactly prototypical speed for both of these craft. And that's what we're really looking for, is somebody who has, you know, found that knowledge base You know, we know from past experience that 4,000 RPM to 5,000 RPM is basically the propeller speed that we're aiming for. That's what we need these boats to move at in order to get a scale-looking appearance. The problem is, boats like the Miss Budweiser here, the propeller on the back of that boat is spinning at 45,000 RPM, roughly 10 times faster than what the Submarine needs. And when you go to the hobby shop and stand there in front of the counter with the guy who is selling either the Traxxas 40-inch long V-hull or the $300 RC stadium truck, he's going to sell you a brushless motor that is 10 times the RPM of what this motor is set up to do. And if you want to go with a direct drive setup, there's actually some programming that you need to do on the speed control, because there's only one brushless motor set up this way that I know of that will do 500 kV with no modification. Most of the rock crawler motors are going to run somewhere between 1200 and 1800 kV. Perhaps I should do some explanation on that. The term kV is basically kilovolt, or 1000 RPM, or let's just say RPM per volt. A lot of your old brushed motors are defined differently. Your Dumas Pittman motors that a lot of people put in their submarines and tugboats, they will basically say that it's a 5,000 RPM motor. And what that generally means is you're missing a piece of information, because you need to know what type of voltage am I getting that 5,000 RPM. And most of them will say something like, on 6 volts, it's a 5,000 RPM motor, or on 12 volts, it's a 5,000 RPM motor. And you need to do that math in this setup, because in this setup, it's a 1200 kV motor. So if it's a 1200 kV motor, on 6 volts, it's going to be doing roughly 7,000 RPM. So it's a little bit hotter motor than what you're expecting in your Pittman type of setup. And the way we get around that is using the rock crawler speed control. Every one of these speed controls, you can buy a little programming card for it, or in the case of the Castle Creations crawler speed controls, you actually get software that runs on a Windows computer and a little USB dongle that connects between the speed control and your computer, and then you run the software and you can change all these configurations on the speed control. But the primary thing we're doing in both cases is we're actually limiting the maximum RPM that the motor can run at. So I've actually got this one configured that he actually is spinning this motor at a maximum of 500 kV. So he's running at 40% of his maximum potential. And I've set that limit in the speed control for both forward and reverse. The other thing I've done with this particular speed control is, because it's in a boat and not a car, you don't want to have to drop into neutral before you put it into reverse. You want to be able to go from full forward to full reverse. So I've removed the brake limit, and I've removed what they call the drag brake. So I don't have to do, sometimes they call it a double bump, sometimes they call it a 3-second delay, but on all of my submarines and brushless boats, they're all configured so that I don't have any delay between forward and reverse. No need to stop it in neutral. And those are basically the only 2 settings that I change in order to get those RC rock crawler speed controls to work correctly in a submarine or a scale boat configuration. In boats like the Miss Budweiser, those are all set up so they have no reverse at all. They're like a model airplane. They go very, very fast in one direction only. And hopefully that's still on top of the water and not below the water, but we won't get into that. This guy likes to dive. So the next step in our conversation this evening, and if you have any questions, go ahead and ask. You can interrupt.
Why a brushless?
Like I said, I'm a brushless bigot, but in the case of model submarines, there is one huge benefit. There is no electrical interference generated by a brushless motor. The concept of having to solder capacitors to your motor is completely alien in a brushless setup. You can literally have, in the case I have right here in the skipjack, the antenna is running within an inch of both the brushless motor and the brushless speed controller. No problem, no glitches, nothing.
What's the approximate cost of that?
Well, that's where the Chinese come in. This motor costs $35, and this speed control costs $35. Now, if you want to skimp, you can find a speed control for as little as $25, and if you want to go in the opposite direction of skimping, you can spend as much as $150 on a motor and as much as $150 on a speed control. And the advantage you get with that $150 motor is, I don't know, because if you look at the specs, they're identical. The advantage you get with, there is one advantage you get with the $150 speed control, and that is the $150 speed control, and get your pencils ready. It's a Castle Creations Mamba Max Pro, and it has the $150 speed control plus the $20 USB dongle allows you to set that governor in single-digit increments. So if you do your math and find out that you need to set your governor at 37% in order to get your 4,000 RPM prop speed, you can set that at 37%. The $35 Chinese one, you are limited at 10% increments. So if you need to be at 37%, you have to flip a coin and either set it at 30% or set it at 40%. But you're not going to be able to get the granularity that you can with that. And for me, it's a no-brainer. I'd rather buy 5 of these and limit myself to the 10% increments.
So that's not a real Castle Creations, it's a Chinese?
This one, I have one Castle Creation speed control that runs my pump, and it's just because I ran out of the $20 Chinese ones. But I actually own, I counted, I have purchased over the last 10 years more than 30 of these Castle Creations. It's now called the Sidewinder Micro, but the original ones that I bought were called the Mamba 25. Yeah. The layout and the design, they look identical. The only difference is the original Mamba 25 had a 25 amp max continuous. Sidewinder is now up to 35 amp continuous. And to be honest with you, these could be 10 amp and they would still be more. On my Holland, I have to run him full throttle, holding him in the bathtub to put enough load on him to actually show up on my meter. And that's when it crosses the 1 amp boundary. Tooling around in the lake here, he pulls about 3/4 of an amp. But that's the second thing that we'll talk about in the future technologies. Getting back to these guys here, I have lipos in every single submarine but the Alvin. I have sealed lead acid gel cells in the Alvin. And that's another big distinction that a lot of people miss. You do not have to put lipo and brushless together. You can run your brushed motors and replace your nickel metal hydride battery packs with a lipo battery pack that's about the same physical size and probably somewhere around 5 ounces of lead, and your boat will be back in the same static trim it was in before. But the power to weight ratio of a lipo battery is almost 2 to 1 over the original NiCads, and it's about 60% more than the nickel metal hydride. I want to go back to the brushless motors, and I want to have a small discussion about the types of brushless motors that are available. And in my simplistic world view, there are 3 types of brushless motors. And I actually have representations of all 3 types in the models that I have on display here. And those 3 types are a brushless outrunner, a brushless inrunner, and what I call a censored brushless inrunner. And in my book, pretty much anything that you can use a brushless inrunner, you can use a brushless outrunner. And the only caveat is because of the design of a brushless outrunner, the outside case of the brushless outrunner is actually the part that spins. So if you're in a position where you have to have something physically touching the can of the motor, you're not going to be able to use an outrunner. But to be honest with you, I'm using an outrunner in this Submarine, this high-speed boat, this scale speed boat, this scale speed boat, and this high-speed boat. I'm also using 3 outrunners in the Alvin. One, the exact same motor is being used for the main motor and the 2 thruster motors. The only difference is the gears in the actual outdrive give this about a 1.5 to 1 reduction, whereas I actually have a planetary gearbox on the main motor that's a 6 to 1 gear reduction. And the whole reason for that is because this thing has a giant 5.5-inch prop, and the propeller on this thing only goes about 650 RPM. And that's the only way I could get that low of a speed out of that motor. I didn't want to have at the time you couldn't program the speed control to have a limiter on it. There are definite quality differences in the brushless outrunners. I'm using basically a Horizon Hobby E-Flight for the 3 motors in this and the motor in the blueback, and there is obvious cogging at low RPM. And what that is basically between 1 and 3 notches above neutral, you will actually see the propeller just twitch. It won't actually move. It'll just sit here and twitch, and once you kick it past that 3rd notch, then you'll see it start to spin. And once it's spinning, I can then actually take that throttle and back down to about 2 notches, and you'll see the propeller slow down. But you actually have to get it above a certain voltage before it starts to spin. It's not that way with the sensored inrunners. With the sensored inrunners, you actually have a harness that has 6 wires on it that are hooked up to Hall sensors built into the motor. And those Hall sensors actually indicate to the speed control both what direction the motor is spinning in and how fast it is spinning. So it can be much more, it has a much higher level of granularity at low RPM. And with those Castle Creation speed controls, you can actually set your throttle curve so that it has a low speed bias. So that's a second reason to spend your money on the $150 speed control. But to be brutally honest, my computerized radio allows me to put that exponential on the transmitter itself, so I don't need that in the speed control. But that's the reason I went with the sensored motor in the Delta and the Skipjack are the most recent machines that I've built. And they have literally the performance where I can go from neutral up 1 notch and the propeller will start spinning. And each time I increase it another notch, you can see the propeller spin slightly faster, all the way up to full throttle. And in the exact opposite way, going down the throttle. So there's none of this cogging that you see. It's really bad on the Alvin, having to move that big mass of that propeller. He cogs like a madman the first time you bring him up.